Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2033, minimum operations to make a uni-value grid. This problem is based on math and sorting algorithms. Also it is marked as medium. Let's try to understand the problem statement. Here we are given a 2D integer grid of size m cross n. Apart from that, another integer x. This is given to us, and what operation we have to perform is, in one operation you can add x or subtract x from any value of the grid, and this is our operation. They are also saying that a uni-value grid is something where all the elements in the grid are equal. What we have to return is minimum number of operations required to make the grid uni-value grid. If it is not possible, then return -1. Now the problem statement is clear. What is given to us is a grid of size m cross n. All are integers. Apart from that, an integer x, and we have to convert this grid to a uni-value grid where all the values are same. Let's say the values are v. If all the values are same, how many operations required, and whatever is the minimum number of operation, we have to return that. So convert this grid to a uni grid. It means all the values are same, and we have to keep in mind that we are requiring minimum number of operations. And what is the operation? Picking any value of the grid and either adding 2 out of it and subtracting 2 from it. So this is the operation. So x value is already given to us. Either we can add x or subtract x from the given value to make it a uni-value grid. Now the problem statement is clear, and we have to apply the operations any number of time, keeping in mind that we are keeping these operations minimum to make it a uni-value grid. So first of all, let's say we have converted the grid and the value is v. It means in the first cell, this first v, we must have added or subtracted the value of 2 multiple times. It means that whatever is the difference, let's say v minus 2, whatever is the difference, that difference is a multiple of 2. It means that is modulus 2 is equal to 0. If I'm using 2 here, is 2 is our x, and taking modulus, v is the value of my new grid, minus, let's say the value of the old grid is a. So v minus a modulus x should be equal to 0, right? Why? Because we have either subtracted x multiple times or added x multiple times. It means whatever is the delta between v and a can be smaller than a v, or a can be like greater than v, or in short you can say that okay, you are taking modulus here. Now let's say I'm picking 8 as a b, value b. In the final grid we are having v, and it means we have reached to v either by adding 2 or subtracting 2. It means the delta between v and b is a multiple of 2. If it is a multiple of 2, then definitely modulus of 2 will be equal to 0. Multiple of x, you can say modulus of x is equal to 0. Okay, so if I just picking a and b, so in short what I can write is v minus a modulus x is equal to 0. v minus b modulus x is equal to 0. If I just try to expand the problem statement, v modulus x is equal to a modulus x, and here in the second statement, v modulus x is equal to b modulus x. So here a modulus x is equal to v modulus x, and b modulus x is equal to v modulus x. The left hand side is same. If the left hand side is same, definitely a taking modulus with x should be equal to b taking modulus with x. And what are these two values, a and b? A and b are the two actual values from the grid, right? If we have to convert, so it shows that 2, 4, 6, 8. if we have to convert this grid to a uni-value grid where all the values are same, the modulus with x for all the values should be same, right? And this is something we have proven with the above statement. Like this is the equation 1, this is the equation 2, and both of these equations are saying us that modulus with x for all the values should be same. If it is not same, then what happened? If it is not same, in that case the answer is not possible and we have to return -1. So if it is not the same, then return -1 directly. If it is same, it means we have to convert these grid values to a different value. If I just try to convert it to let's say 0, x is 2 in this case. If I have to convert it to 0, 0, 0, 0, 0, how many operations do we require? First, for the first value, for 2, to convert it to 0, I require 1 operation. For 4, I require 2 operation. For 6, I require 3 operation, because 6 minus 2 minus 2 minus 2, 3 operations. And for 8, I require 4 operation. 4, 5, 6, 7, 8, 9, 10. 10 operations are required. But we have to keep in mind that our operations are minimal. If let's say I try to convert it to 2, in that case the uni-value grid will look like this. In this case, what are the operations? For first value, we don't require any operation. For second value, 1 operation is required. For third value, for 6, 2 operations are required. And for 8, 8 minus 2 minus 2 minus 2, 3 operations are required. 3, 4, 5, 6, 6 operations are required. In this case, 10 operations are required. Now if I try to convert it to 4, in this case, how many operations do we require? 2 will be incremented by 2 only once. So in 2, I just add 2. 4 will remain same, 0 operation. 6 minus 2, 1 operation. 8 minus 2 minus 2, 2 operations. So in total, we require 4 operations. And so far, 4 is the minimum. Now if I try to convert it to 6, let's convert it to 6. In 6, how many operations are there? For 2, 3, 4, 5, 6. 2 plus 1 plus 0 plus 1. Here also we require 4 operations. And now what about 8? 8, 8, 8, 8. This 8 requires 0 operations. This 8 require 1 operation. This 8 require 2 operation. This 8 require 3 operation. 3, 4, 5, 6. 6 operations in number. It means that these values are going to give us the minimum number of operations. And what are these two values? If I just stretch the grid to a single dynamic array, 2, 4, 6, 8. 2, 4, 6, 8 is my grid. If I just try to convert it to a list, it will look something like this. 2, 4, 6, 8. And what is the middle value? Middle value in this grid. These are the middle value. Why they are giving the least number of operation? Because they are the medians. And in this case, we are going to pick any number from the grid itself, because at least that number is going to give me the 0 number of operation. Let's say in this case I picked 6. So at least for this cell, we require 0 operation. So definitely let's pick the element from the grid itself and pick the middle element. So what I did is, first of all I converted to list, and second I can sort. Third, I will pick the middle element and I will try to choose that element. Let's say pick the middle element. I have picked 4 and I will try to convert every single element to 4. But instead, if I am converting the grid to 4, and 4 itself is from grid, and from the above equation, every element taking modulus with x should be same. So every element, like see, 4 is definitely from the grid, and if I take modulus with x, let's say in this case it is coming m mod, so every other element should give the same mod. So this equation I can check while doing the iteration over the grid over these values, and I can figure out like whenever ith item taking modulus with x is not equal to desired element modulus with x, in that case return -1. So converting to list, m cross n size list, sorting is m cross n log m cross n log n time complexity for sorting. Finding the middle element, directly find the middle element n by 2, whatever is the value, and after that just do one more iteration and figure out the number of operations required. See, and how do we figure out the number of operations required? So this is 2. What is the difference between 2 and the desired element? This 4 is my desired element because 4 is the middle element. Just check the difference. This is the difference divided by x. This will give me how many times we have used x to convert 2 to 4. So using this value, just pick for every single element. Now now let's check the code. Here the time complexity will be n log n, where this n is equal to size of the grid, total number of element in the grid. And what about the space? Space is number of elements we are getting in the starting, because we are converting those elements to list. Let's write the code for this approach. Here first of all we have to flatten the grid, and for that I can take an array list. Array list of integer list equal to new array list. Just iterate over the grid, I equal to 0, I less than grid dot length I plus plus int j for j pointer j less than grid 0 dot length. It's already given in the constraints that we are going to have at least one row, so no need to check for the condition. J plus plus, this is the grid iteration, and add every element from the grid I j to this list. Now we have added all the elements in the grid. Collections dot sort list. This list is sorted, and we are going to pick a common item to which we are going to convert every single value of this grid. Int, let's say that is middle list dot get, that's a list of list length divided by 2, and what's the length of this grid? Int length is equal to list dot size. So this is the middle value, and now iterate over every single list item. I equal to 0, I less than length I plus plus. Now we have to check one very important condition, that every item list dot get I taking modulus with x should be if it is not equal to the middle item taking modulus with x. In short, we are comparing every single element modulus with x. If it is not equal to, then we can directly return -1. It means the answer is not possible. Otherwise the answer is possible. Just capture the number of steps, and in the end return the number of steps. And what is the initialized value of number of steps? Number of operations, that is 0. Result plus equal to whatever is the difference. See, we are going to convert value a to value b by adding or subtracting x. It means we have to capture how many times we have used x. So whatever is the delta. What is the delta? Math.abs. Delta is middle value is the one where we have converted the value, and what is the current value? List.get I. This is the current value. This is the delta, and how many times we have used x divided by x. This will give me how many times we have used x. Now let's test over sample test cases. Sample test cases are passed. I am submitting the problem. it got submitted successfully. I hope you understood the approach. In case you get any doubt, you can discuss below in the comment section. Thank you guys. Bye bye.